recording. I have no idea why.
Yeah, get rid of the big recording set.
Yeah, and second recording, it'll always shut off. But then it'll go just fine after that. So
30 minutes of math is just too much for this computer.
I know. It's ready to pop. All right, so our third reference angle. No, that was right. In quadrant 3 is equal to theta minus pi. And our fourth reference angle, 2 pi minus theta. Quadrant 4. Okay. So we know that in this case, our theta is equal to pi over 3. That's just for positive 1/2.
You move it up.
Oh, there you go.
Thank you.
Mm-hmm. Okay. But we know that x is going to be negative in quadrant 2 and quadrant 3. No, not 4, but in quadrant 2 and 3. Okay, so that means we have to find our reference angle for both of those sections, or quadrants. Okay, so in quadrant 2, that means you have cosine of pi minus theta, which means that's going to give us cosine of pi minus pi over 3. Which is negative 1/2. Okay, so we know that pi minus pi 3 pi over 3, so that's cosine of 2 pi over 3. Would give us negative 1/2. Okay, so we know in quadrant 3, that would be cosine of theta minus pi. Which would give us cosine, remember our theta is pi over 3, minus pi, equals negative 1/2. Excuse me. Okay, so if we subtract 3 pi over 3, we end up with cosine of 2 pi over 3, negative 2 pi over 3, equals negative 1/2. So we know just from there that theta would have to equal 2 pi over 3.
You move it up again.
Oh, sure. There you go. Either positive or negative. Which is just one of the answers, because remember, it's an infinite number. So we have that plus 2n pi. Remember, wherever you end up, if you just keep going in a circle over and over and over, it'll still be the same answer. Okay, so the actual zeros for r equals 4 cosine of theta plus 2 is, remember, it has to be in the form r theta. So that would be 0, 2 pi over 3, and 0, negative 2 pi over 3. Uh-oh. I guess you could say not these zeros, but just zeros. Hmm? Yep, because remember you set your r equal to 0. Clean that up a little. Okay. Now you can keep going and going and going, but that's pretty much okay there. They might ask for that formula. You know, let me put that as an option because they might ask for it, just in case. So 0 2 pi over 3 plus 2n pi, and 0 to negative 2 pi over 3 plus 2n pi. But to be honest, once you put the 2n pi, it's kind of, well, I guess you can put both just to, they'll tell you which form they want it in. So I think it may change depending on the question. All right. So any questions on this one? All right. It's a little bit of a throwback to the trig you were probably hoping you'd never see again. All right, leave that up for a little bit. All right. Okay, now this one is going to go over the maxima for polar equations. Okay, and for this one, you really only have to, well, not only, but you just have to go back and remember two main things. That sine of x, or sine of theta, we'll use theta instead, is between -1 and 1. Okay, where we know that 1 is the maximum value, because if you have sine, it's not going to go any higher than 1. Okay, and that's only if theta equals pi over 2 plus 2n pi. I'll put my theta there. Okay, so once you get pi over 2, it just keeps repeating every 2 pi. And same thing for cosine of theta. It's between -1 and 1. Excuse me. Or once again, 1 is the max value of cosine of theta. Where since cosine 0 is 1, that means theta would have to equal 0 plus 2n pi. Or theta could just equal 2n pi. I just kind of put the 0 as a starting point. Okay, so let's say, for example, find the max value of, let's say for problem A, r equals 3 cosine of theta minus 3. Let's say for problem B, r equals 8 sine of theta. Okay. Now we know in this case the maximum value of cosine is 1. So that means that r equals 3 cosine theta minus 3 will have a max value. You can put that little r max there if you want to. You don't have to. That's going to equal 3 times the maximum value of cosine, which is 1, minus 3. That means the maximum value here is going to be 0. Okay, so that means the max value is going to be 0, 0. Because remember, cosine starts at 0. Or you can go 0 plus 2n pi if you want to, but... And they'll pretty much tell you which form they want the answer in.
If it's r theta, wouldn't it be 0, comma 0 plus 2 and pi? Not 0 plus 2.
Oh, yep, other way around. Oh, I'll put the 0 there. Like I said, you don't have to put the 0, but... All right. Now for B, we do the same thing. Max value of sine theta is 1. So that means your r equals 8 sine of theta. It's going to have a max value of 8 times 1, which is just 8. Okay, so that means your max value is going to be r theta, so that's going to be 8. And your theta, remember it's pi over 2 plus 2n pi. And again, they'll let you know which one they want it in. All right. So any questions on that one? All right. Okay, so now we're going to go to the area and arc length of a polar coordinate. Oh yeah, I got enough time. Okay, so we're going to skip the proof since we're trying to play catch up right about now. I'll include it in the notes. So if you want to go over it, you're interested, you're more than welcome, but you don't have to know it. Okay. Is equal to integral from alpha to beta, 1/2 radius squared with respect to theta. I hate being behind because that proof is actually fun. All right, so let's say, for example, let's take up a whole page. Yeah, I'll start with a new page. All right, anyone still writing this one? We'll leave it up for a few seconds. All right. Okay, so let's say, for example, I want to find the area of, well, they call it one petal of the rose curve given by r equals 3 cosine of 3 theta. Okay. Now this is one of those cases where if you know how to graph on your graphing calculator, it helps because you can kind of avoid this first step. But if you don't, you can actually still find out where to go. Okay. So the first thing you want to do cosine of 3 theta equals 0. Okay. So we know cosine of 3 theta equals 0 when 3 theta is equal to pi over 2, 3 pi over 2, 5 pi over 2, yada, yada, yada. So cosine, I kind of separate that a little bit. 3 theta equals 0 when 3 theta is equal to, I guess you could say plus or minus since it's symmetric across the origin, the pi over 2. And it keeps on going. Okay. So that means if we divide both sides by 3, that means that theta would have to equal plus or minus pi over 6, plus or minus 3 pi over 6, which is just pi over 2, plus or minus 5 pi over 6, and et cetera, and so on. Okay, so now what we're going to do is we're going to actually graph it. And the same way you graph a polar equation is the same way you graph just a regular function. You pick points and you plug it in. Okay, so you pick values of theta and you plug it into your r equals 3 cosine of 3 theta. Okay, so since we know it equals 0 between plus or minus pi over 6, we'll actually pick the plus or minus pi over 6. Okay, so we'll start at negative pi over 6 and negative pi over 8. You can pick any values between them that you want. These are just ones I happen to pick. Negative pi over 10, negative pi over 12, 0. Then we go the other direction with pi over 12. Make that a little bit longer. And pi over 10, pi over 8, and pi over 6. Okay. So if you plug in negative pi over 6, you end up with 0 because you end up with 3 pi over 6, which is pi over 2, cosine of pi over 2, 0. Okay. If you plug in pi over 8, you end up actually with 1.14. You plug in negative pi over 10, you end up with 1.76. Negative pi over 12, 2.12. You plug in 0, you end up with 3. Cosine of 0 is 1, 3 times 1 is 3. And if you plug in pi over 2, remember cosine of negative pi over 2. Pi over 12 is just pi over 12. So you end up right back at 2.12, 1.76, 1.14, and 0. All right, so now we're going to use that not given information, the information we actually found, to graph 3 times cosine of 3 theta. Okay, so we know that this is the, oh, don't need it that high up. Say this is power over 6, and that's negative power 6. And let's say this is 3. Okay. So we know when theta is equal to negative power over 6, your radius is 0, which means you're still at the origin. Okay. Theta equals negative power over 8, you're at 1.14. So negative power over 8 is just a little bit that way. I'll make it a little further out. Say 1.14. Okay. So it's negative power over 10 is 1.76. So you go out 1.76 down negative power over 10. Nope, should be out a little bit further than that. That's about right, give or take. Okay. So negative power over 12, your radius is 2.12. So you go out to 2, let's say that's 2 just to mark where I am. So you're going to be about right there. Okay. Hmm?
It's just weird because you have the 1.14 to the left of the 1. Where you
No.
put the marker, that's all.
No. I know, which is why I normally don't put the ones there, but because it's never going to line up exactly when you draw it out. Okay. And when that theta is equal to 0, your radius is 3, so you end up right there. Then it kind of goes all the way back around. So 2.12, 1.76, 1.14, right back at 0. So this one, I guess you can call it petal, which looks nothing like a petal to me, but for some reason they call it that. It's going to look like that. Now the graph in all will look, I'll just fill in the other 2, it'll look kind of like that.
It just keeps going around.
Yep, and then it just,
It's just circular.
yep, keeps repeating over and over. Okay, but we're just going to worry about that section. But if you wanted to, you could have used 3 power over 6 to negative 3 power over 6, or it would have just gone the same thing and just, so any one of them you could have used. And that's why I was saying that if you have a graphing calculator and you can figure out how to graph it, you can kind of look and say, once you figure out negative power over positive or negative power over 6, you can just say, okay, if I graph it, this looks to be between positive and negative power over 6, so I'll just figure out that one. So, kind of helps. Like I said, this step is only necessary if you don't graph it out. If you do graph it out, you can kind of figure it out from there. All right. So now, since we know that the area is equal to, might as well put the 1/2 out there. Radius squared with respect to theta. That means our area is equal to 1/2 from negative power over 6 to pi over 6 of 3 cosine of 3 theta squared with respect to theta. Okay, Okay, which means you have, I could have just put the equal sign there. I'll do it over here. The area is equal to 1/2 negative pi over 6 to pi over 6 of 9 cosine squared 3 theta. Or if you want, you can just bring the 9 right on up front. You don't have to leave it there. So that's 9 over 2 from negative pi over 6 to pi over 6 cosine squared 3 theta. Bring that up. Nope, respect the theta. Okay. Now we know, I'll use the little side note here, that cosine squared of, we'll say u, is equal to 1 plus, oh, nope, 1 plus, nope, 1 minus. Nope, I think sine is 1 minus.
Yeah, cosine
Yeah,
plus.
plus. 1 plus cosine of 2u over 2. All right, so that means we have, bring that up just a hair. So 9 over 2 times the integral of negative pi over 6 to pi over 6. You can make that 1/2 plus 1/2 of cosine 2u. Which, remember, our u is actually 3 theta. So that makes it 6 theta. With respect to theta.
Should be 1/2 plus 1/2 cosine 6 theta, right?
Yep, 1/2. Actually, that's why in my notes I actually factored that out, so that's why.
Oh, okay, you just put the over 2 on the outside right away.
Yep. So actually, you can just make that 9 over 4.
We did a u substitution of 3 theta, right?
Yep.
Then shouldn't we consider putting the, like, divide by 1/3 in the integral?
Divide by 1/3. Oh, we didn't integrate yet.
I don't think we did.
Nope.
I don't think we did a new substitution. That was just a.
Oh, no, this was just the general formula showing that
I'm-
there.
I'm
Oh,
cool.
yeah.
I was about to say, I was confused there.
Oh, no. I actually thought I'd use you to make it least confusing. I think I confused you more using you. Yep, this is just a general formula. All right. Okay, so that means we have 9 over 4 from negative pi over 6 to pi over 6. 1 plus cosine of 6 theta respect to theta. So that actually gives us 9 over 4 theta plus, 1/6 sine of 6 theta. From negative pi over 6 to pi over 6. Okay. Actually, on this one, because cosine is an even function, if you wanted to, you could have actually just made this 2 times from 0 to pi over 6 if you wanted to, but you don't have to. That's one of those